Okie doke. Let's deal with some integrals of tangent and secant. We want to find the integrals of tangent and secant, but at this point in time, I'm just gonna write it for tangent. You know, natural log of the absolute value of secant plus c, or possibly you write it like this. It's just reduced down because if you treat this as the exponent, the inverse of cosine is just secant, and that's why those formulas are the same. But let's deal with the integral of secant. That's not why we're here. We're not here for the integral of tangent. If you couldn't do that to start off, if you're this far into the class and you can't find the integral of tangent, you might want to rethink taking this class this semester, because good guy. I mean, you've done it. All right. Now this one. Oh, man, this one. There's a special one that we need to multiply by. It's a very special one. And somebody had too much time on their hands, I believe. You know what I mean? So we're going to multiply by a fraction, just a special one. And it's secant plus tangent over secant plus tangent. Clearly, right? You saw that. You're like, oh, yeah, just multiply by secant plus tangent over secant plus tangent. Yeah? Oh, yeah, me too. Me too. I didn't have to look this up before making the video because I can never remember what to multiply by. No. So let's bring this in and see what we end up with. So we're going to get a secant squared. Hey, that's the derivative of tangent. All right, and then secant times tangent. Hey, wait a second. That's the derivative of secant. Would it be, you mind if I just turn this around and just write it as tangent of x plus secant of x down below? Too much time on someone's hands, I tell you what. All right, so now we're going to just say that u is equal to the denominator. And then du is, well, the derivative of tangent is secant squared. Hey, that's the first term. Plus the derivative of secant, which is secant tangent. Oh. Hey, that's exactly what we have written up top. What a nerd. Huh? So we get 1 over u du. My goodness. Some nerds, man. How'd they ever come up with this stuff? I don't know about you, but I'm not very good at creativity. I don't come up with things very well. I'm very good at parroting what somebody else tells me. So this fascinates me. Like, who came up with that? So we ended up with a natural log of the absolute value of tangent plus secant. That is the integral of secant of x. This is one of those I highly advise that you memorize. Unless you can memorize this process, which if you can memorize the process, I'm guessing you could probably just memorize the gosh darn integral. This is one of those you want to memorize. Have it down. Okay. We keep going. This might, like I said, this one might be a longer one. Now I want to deal with tangent cubed of x. We got this. We got this. So this is coming back into some rules where, wait a second. Let's break off a tangent. Let's break off a tangent. And it's not one of the typical rules, but we're like, well, wait a second. Let's call this tangent of x times tangent squared of x dx. Now, we know that tangent squared of x from prior videos is equal to secant squared of x minus 1. So let's replace that in. All right, let's go. We can bring this in. Got it. So now we have the integral of tangent of x times secant squared of x. Hey, that's a simple one. Minus tangent of x. Yeah. Wait a second. I think we can do this one not so bad. I'm going to break this up into two different integrals because we have to do a u sub on one, which means technically we're doing a u sub on 2, but we're just going to write down the integral of tangent of x. So over on our right-hand side, we'd have to say that u is equal to tangent of x, and that du is equal to secant squared of x dx. And that one works out very, very nicely. So we just end up with u du minus our integral of tangent of x, which we're just going to write down. All right. See? We probably just want to know, Melissa, do you want to do a u sub every single time on tangent and not have that down? I'm too lazy for that crap. So let's take an antiderivative on u. So that's going to be u squared over 2. And we get a plus c, but it's just going to get wrapped up into the other plus c it's already written down. And now we can replace our u with a tangent, and we find out our answer is tangent squared of x over 2 minus the natural log of secant of x plus c. Now this one, I don't know if I'd wasted any brain space memorizing this one for tangent cubed. But knowing how to get there, I think it'd be a great idea. All right. Now for the big one. Now for the beast. Oh my goodness. This is another one that I had memorized as a student. And here it comes. So we've done tangent. We've done secant. We did tangent cubed, so now here it comes. Secant cubed of x. Secant to an odd power by itself is a pain in the butt. So I think it might be in our best interest to note secant cubed and secant, if nothing else. All right. Let's jump at it. So we're going to do this by parts. So I'm going to call this secant of x times secant squared of x dx. So let's let our u be secant of x, and let's let our dv be secant squared of x dx. So the derivative on u is secant of x tangent of x. And then our dx. And our v is just going to become tangent of x. All right, all right. What is that? uv minus the integral of v du. So uv, so it's going to be secant of x tangent of x minus the integral of v du. So we're going to end up with what? A tangent squared of x secant of x dx. Well, let's change that tangent squared over on the right-hand side. Right? Tangent is just secant squared of x minus 1. So we'll replace that in. Secant squared of x minus 1 times our secant of x dx. Let's bring it in. And, oh my goodness. Integral of, and now we have, oh, there's another secant cubed. That sucks. Man. But, wait a second. Wait a second. Oh, shoot, I forgot that there's a, okay, yeah. There we go. Why don't we break this integral into 2 pieces? I'm going to bring the negative over to here too. So we're going to end up with this. Secant of x tangent of x minus the integral of secant cubed of x dx. And then plus the integral of secant of x dx. Do you still remember the integral of secant of x? Do you still remember it? Do you remember? Should we go back up? Should we go look at it? Nah, let's not. So I'm going to put this one first, okay? There's a reason why. So that was equal to the natural log of the absolute value of secant of x plus tangent of x minus this integral of secant cubed of x dx. But wait a second. Wait a second. Wait a second. Isn't this what we started with? We're looking for the integral of secant cubed of x dx. It's equal to this. You see that this matches over on this side? So let's add it over. Let's add this over to the other side. The other side of this equal sign. Are you seeing why you might want to memorize this instead of having to actually do it? Because your teacher is going to ask you at some point in time about this. Oops. So now we have two integrals of secant cubed of x is equal to secant of x tangent of x plus the natural log of the absolute value of secant of x plus tangent of x plus c, of course. Now let's divide by 2. And we find out that the integral of secant cubed of x is equal to 1/2 secant of x tangent of x plus the natural log of secant of x plus tangent of x. Oops. All plus c. Do you really want to do that? Or would you just like to memorize up this formula here? And it's not so bad with the memorization. Like secant cubed, it's like it's got secants and tangents. It's 1/2 of secant times tangent plus the integral of secant. All plus c. It's up to you. So there we go. We just went through and did some tough ones. You will see secant cubed and you will see secant again. Get those dialed in. Tangent, yeah, whatever. You can build that yourself. Tangent cubed, you can build that shit yourself too. Sorry about the swearing. Excuse me. But yeah, there it is. I think we're going to do one more. We'll do a couple tough problems. And then let's finish this sucker up and we can move on to inverse trigonometric substitution or just trigonometric substitution. All right, let's see.